Welcome to today's deep dive. We're looking into a newly published March 2026 structural engineering paper. And our mission for you today is pretty straightforward. We are exploring how scientists are supercharging everyday aluminum using nanotechnology and sound waves, all without getting bogged down in the dense jargon.
Yeah, it is a really clever piece of research. I mean, they took a material we already rely on heavily and just fundamentally changed its mechanical limits at a microscopic level.
Right. Okay, let's unpack this. We're dealing with Al6061. It is obviously an industry workhorse for cars and airplanes because it is, well, lightweight and corrosion resistant. But the downside is that it is just too soft and prone to wear over time.
Exactly. Yeah, it is simply too soft for certain high-stress applications over the long haul, which is why this paper tackles that flaw by building what they call a hybrid metal matrix composite that basically reinforced the metal using microscopic ceramic dust. Specifically, they added alumina for extreme hardness and zirconia to stop cracks from spreading.
But getting those ceramics into the mix seems like a logistical nightmare. And you try mixing nano dust into liquid metal, and it is like trying to stir dry cocoa powder into cold milk. It just clumps up and floats to the top. So how did they actually get it to distribute evenly?
Right. What's fascinating here is they bypassed that problem completely using ultrasonic assisted stir casting. They took the molten aluminum at 750 degrees Celsius and basically blasted it with high energy sound waves.
Wait, so the sound waves are essentially doing the stirring.
Yeah, more like microscopic blasting, really. The acoustic waves trigger these tiny cavitation bubbles throughout the liquid metal. And because of the extreme heat and pressure, those bubbles violently burst. Those tiny explosions completely shatter the ceramic clumps, which spreads the nanoparticles perfectly evenly.
Here's where it gets really interesting. Getting the dust to mix is one thing, but finding the exact right proportions is the real breakthrough here. They discovered a Goldilocks ratio of exactly 1% alumina, 1% zirconia. That perfect recipe boosted the metal's fracture toughness, meaning its ability to resist cracking under stress by a massive 47.39%.
That 47% jump is massive. But there is a crucial twist to the data. You would assume that bumping the zirconia up to, say, 1.25% would make it even stronger. But the researchers found the material actually got weaker. Electron microscope images showed exactly why. The extra powder caused the particles to clump together all over again, creating brittle stress points.
So the acoustic blasting just could not overcome that sheer volume of powder.
Precisely. The system was overloaded. Instead of reinforcing the metal, those new clumps created localized brittle zones that made the alloy much easier to fracture under a load.
So what does this all mean? Well, optimizing these hybrid metals means manufacturing lighter, stronger vehicles and aircraft. That directly translates to better fuel efficiency, lower emissions, and safer everyday travel for you.
If we connect this to the bigger picture, true engineering isn't about just adding maximum strength. It is about finding the perfect balance and distribution of elements. The structural magic always lies in the harmony of the ingredients.
It really is all about that perfect blend, and it leaves us with a compelling thought to close on. If we can use acoustic sound waves to force ceramics and liquid metal into a perfect blend, what other impossible futuristic materials could we create next simply by manipulating sound? Something for you to mull over until our next deep dive.